Hello students and good morning. So today I am continuing class for class 2 of science. The topic is integration of some special form of functions. And in the last online class also we did some problems on this chapter, integration of some special form of functions. So today we are continuing this chapter, right? So this is question number 31. So in the last online class we did up to question number 30. So let's do this question number 31. That is, you have to integrate integration of x dx divided by x plus 1 into 2x plus 1. So in this case, we have x upon x plus 1 into 2x plus 1. The denominator is factorized here. That is, the denominator is in terms of factors, right? One factor is x plus 1 and the other factor is 2x plus 1. So you have to convert it into partial fraction. So I told you about the meaning of partial fraction while doing differentiation also, right? So how can you convert this fraction into partial fraction? Before that, you should consider the highest power of x both in the numerator as well as in the denominator. So in this case, the highest power of x in the numerator is 1, and in the denominator, if you multiply these two factors, the highest power of x will be 2. That is, x into 2x is 2x squared. That is, the highest power of x in the denominator is 2. That is, if the highest power of x in the numerator is less than that of highest power of x in the denominator, then you can directly convert this fraction into partial fraction. Otherwise, you can't do it. Okay? That is, if the highest power of x in the numerator is more than that of highest power of x in the denominator, then you have to divide the numerator by the denominator. Then only you can convert that fraction in terms of partial fraction. But in this particular problem, the highest power of x in the numerator is less than the highest power of x in the denominator. Is that clear? So in this case, directly you can change this fraction in terms of partial fraction. So in the previous classes I already told you about the meaning of the partial fraction. So let us convert this fraction into partial fraction first, then you can easily integrate them. Okay, so let us write it first. So I is equal to integration of, this is x dx divided by x plus 1 into 2x plus 1. Let us write I is equal to, that means we are integrating it. Okay, so let us convert this fraction. That is, let us simplify the fraction, or let us convert x upon x plus 1 into 2x plus 1 in terms of partial fraction. Okay, let x upon x plus 1 into 2x plus 1 is equal to some constant, that is capital A divided by. So this is the method of converting fraction in terms of partial fraction, right? So A is a constant here. A divided, what is the first factor here? X plus 1 plus, then we can write capital B is another constant divided by another factor. What is another factor here? It is 2x plus 1. Let us mark it as number 1. Okay. Now our job is to find out the values of this constant A and B. So how can we find it? Okay, so let us find out the values for A and B from this number 1. Okay, and again you have to get the values of A and B, and again you have to put those values of A and B in 1, so that the fraction can be converted into partial fraction. Okay, so or let us keep the left hand side as it is. This is x plus 1 into 2x plus 1 is equal to, what's the LCM out here now? The LCM here is x plus 1 into 2x plus 1 is the LCM. So the numerator becomes now a into x plus 1 gets cancelled. So it is 2x plus 1 plus b into, now this is x plus 1. Is that clear? So now here you can cancel this LCM, right? Or x is equal to a into 2x plus 1 plus b into, this is your x plus 1, right? So now from this we can get the values of this two constants a and b, right? So in order to get the value for b, you have to make this first term 0. If you want to get the value of b, you have to make this first term 0. So how can you make this first term 0? By putting the suitable value of x, we can make this first term as 0. That is, if we put x is equal to minus half. If we put x is equal to minus half, then 2 gets cancels. So minus 1 plus 1 is 0. You know that, right? So putting x is equal to minus half. So putting x is equal to minus half, what do we get? This x is minus half, right? So you know that this x is minus half is equal to, this term is 0, right? So b into, what is x here? This is minus half plus 1, or this is minus half is equal to b into, what is minus half plus 1? It is half, right? So 2 gets cancels. So what is the value for b? b is equal to minus 1. So I think you have understood it, right? So next, now we have to get the value for a. In order to get the value of a, this second term should be made 0 by putting x is equal to minus 1. Since x plus 1 is there, so in order to make this second term 0, you put x is equal to minus 1. So putting x is equal to minus 1 here, right? So in this expression, we put x is equal to minus 1. So putting x is equal to minus 1. Putting x is equal to minus 1, what do we get? So instead of x, you put minus 1 is equal to, then a into 2x is there, 2 into minus 1, right? 2 into minus 1 plus 1, right? And this minus 1 plus 1 is 0, b into 0 is 0, right? So or minus 1 is equal to, this is minus 1 is equal to a into minus 2 plus 1. Or minus 1 is equal to a into minus 1. From both the sides, you can cancel this minus sign. Or what is the value for capital A? Capital A is equal to 1. Is that clear? So now we have got both the values of a and b. So let us put these values of a and b in 1. So putting the values of a and b in number 1, right? So what do we get now? Therefore, this left hand side remains as it is, x upon x plus 1 into 2x plus 1 is equal to, what was the value for capital A? What was the value for capital A is 1, right? So it is 1 upon x plus 1. Is that clear? Then plus sign is there, or plus b, but the value for b is what? B is minus 1. So we can write plus into minus is minus. So it is minus 1 upon, this is 2x plus 1. Okay? So we have converted the given fraction in terms of partial fraction. So I think I've understood it. Or you can check whether these values of a and b are correct or wrong. Okay? If you simplify this expression, you should get this left hand side. So let us check it. So what's the LCM of x plus 1 and 2x plus 1? It is x plus 1 into 2x plus 1, right? So here it will be 2x plus 1 minus x, minus into plus minus 1. So 1 gets cancelled and 2x minus x is x. You can say it. So it is correct. So you will get in the numerator x divided by x plus 1 into 2x plus 1. So I think I've understood it. So we have converted this given fraction in terms of partial fraction. And this is known as what? This is your partial fraction. So now let us put this partial fraction in I. Okay. So therefore I is equal to, this is integration of, so instead of x upon x plus 1 into x plus 1, you should write down the partial fraction. So here the partial fraction is 1 upon x plus 1 minus 1 upon 2x plus 1 into dx. Is that clear? So now if you can convert the given fraction in terms of partial fraction, then you can easily integrate it. Okay? So or now you can separate this integration. This is just like your multiplication. I is equal to integral sine 1 into dx divided by x plus 1 minus integration of 1 into dx is dx divided by, this is your what, 2x plus 1. Now we can easily integrate this to integration, right? So here the power of x is 1. You can directly use dx by x form. So you know the integration formula. So you can assume x plus 1 as x. What is the integration of dx by x? It will be log within mod x plus 1, the base is e, whole divided by. Actually, which function was taken as x? X plus 1. You should differentiate that one. You know that, isn't it? What is the differentiation of x plus 1? It is 1. But in case of integration, you should divide it by 1. You should divide it by the differentiation of x plus 1, right? That is log within mod x plus 1 base e divided by 1. Minus, similarly here also, the power of x is 1. You can take this 2x plus 1 as x. But if the power of x is 2 or 3, you cannot take this 2x plus 1 or 2x, sorry, if the power of x is 2, you cannot take this 2x square plus 1 as x. If there is cube, 2x cube plus 1, that is also, you cannot take it as x. But if the power of x is 1, you can take it as x. So integration of dx divided by x is always log x. So we are taking this 2x plus 1 as x because here the power of x is 1. So what is this integration again? It is log within mod 2x plus 1, the base is e, whole divided by. In case of differentiation, you can multiply the expression by the differentiation of the function which is termed as x. But in this case, since this is integration, you have to divide it by the differentiation of the function which is assumed as x. That is, 2x plus 1 is assumed as x. So what is this differentiation? 2 into d by dx by x is 1, so it is 2. And for 1 it is 0, so it is 2. Then you have to write down plus c. You know that this is indefinite integration. You have to write down plus c. So the final answer is, or I is equal to log within mod x plus 1, the base is e, then minus half log within mod 2x plus 1, the base is e, then plus c. So this is the final answer for this question. So I think you have understood it. So you can copy it. Now we'll do the next problem. So now we'll do question number 33. Before that, this question number 32 is your homework. That is, you have to integrate integral sine x minus 1 dx divided by x plus 2 into x minus 3. So in this case also this fraction can be converted into partial fraction. So you can assume let x minus 1 upon x plus 2 into x minus 3 as is equal to capital A divided by first factor x plus 2 plus capital B divided by second factor, that is x minus 3. So this is your homework. So question number 32 is your homework. Now let's do this question number 33. So you have to integrate integral sine x minus 1 into dx divided by 6x square plus x minus 1. So let us write here I is equal to integration of x minus 1 dx divided by 6x square plus x minus 1. Okay. Now in this case also, the highest power of x in the numerator is less than the highest power of x in the denominator. So in this case, first of all you have to factorize the denominator. Then you can convert this fraction into partial fraction. So you can factorize this denominator, right? So let us write here denominator. What is denominator here? It is 6x square plus x minus 1. So how can you factorize it? You can use middle term breaking. You know how to factorize it, right? So which is equal to 6x square plus 6 into 1 is 6. If you multiply the two numbers, you should get 6. And if you subtract the two numbers, you should get 1. That is the coefficient of x here is 1. So if you subtract that two numbers, you should get 1. If you multiply the two numbers, you should get 6. And if you subtract the same number, you should get 1. That is 3 2s are 6 and 3 minus 2 is 1. So plus, so it is 3 minus 2 into x minus 1, which is equal to 6x square plus 3x. 3 into x is 3x, plus and minus 2x minus 1, which is equal to, what is common out here? It is 3x. Within bracket we have 2x plus 1. Minus 1 common here, so it is 2x plus 1, so which is equal to, this is 2x plus 1 into 3x minus 1. So it is factorized, right? So let us write down the factorization here. So therefore capital I is equal to integration of x minus 1 dx divided by what? So what are its factors? It is 2x plus 1 into 3x minus 1. Is that clear now? So let us convert this fraction in terms of partial fraction. So now you know how to convert it. So let x minus 1 divided by 2x plus 1 divided by 3x minus 1. Whatever expression is there in the numerator, whether it is constant or variable, you have to write constant a divided by first factor. What is the first factor? It is 2x plus 1, right? Then plus, always write plus. You may write minus also, okay? It doesn't matter whether you write plus or minus sign, okay? So plus another constant, capital B divided by, what is the second factor here? It is 3x minus 1. So let us mark it number 1. Now our job is to find out the values of this constant a and b, right? So how can you find it? Let us simplify it. Or x minus 1 divided by 2x plus 1 into 3x minus 1, which is equal to, so what's the LCM out here? It is 2x plus 1 into 3x minus 1, right? So now let us simplify it. So here 2x plus 1 gets cancels. So a into 3x minus 1 plus b into, again here 3x minus 1 gets cancels. You'll get 2x plus 1, right? So here these denominators will be cancelled, or x minus 1 is equal to a into 3x minus 1 plus b into, this is your 2x plus 1. So I think you have understood it, okay? So now, so I already told you that in order to get the value for this constant capital A, you should make this second term, that is term containing b, as 0, okay? So in order to convert this second term into 0, we have to put x is equal to minus half. So if you put x is equal to minus half, 2 gets cancelled, minus 1 plus 1 is 0. So putting x is equal to minus half. So what do we get? Oh, now this is minus half minus 1. You have to put the value for x here also, minus half, right? So a into 3 into minus half minus 1, 3 into minus half minus 1, then this is automatically 0, right? So or now this is 2 ones are 2, minus 1 minus 2 is minus 3 by 2 is equal to a into, how much is this? Minus 3 minus 2, this is minus 5 by 2. So here this 2 gets cancels, minus minus gets cancels. So what is the value for capital A? So capital A is equal to 3 upon 5. So we got the value for A. We got the value for A as is equal to 3 by 5, right? So next. So next one is, so in order to get the value for B, you have to make this first term 0. In order to get the value for B, you have to make this first term as 0. So how can you make this first term as 0? By putting x is equal to 1 upon 3. If you put x is equal to 1 upon 3, 3 gets cancelled, you get 1, 1 minus 1 is 0. So here let us write putting x is equal to 1 upon 3. So let us put it out here, or 1 upon 3 minus 1, because there is x minus 1, the value for x is 1/3 minus 1 is equal to this first term is 0 plus b into 2 into what? 1 upon 3, then it is plus 1, right? So I think you have understood it. So let us simplify it now. Or now this is minus 2 by 3, this is simplified, b into, now this is 5 by 3. So here 3 gets cancels. So what is the value for b? Therefore b is equal to minus 2 upon 5. So we have got the value for b, right? So let us put these values of a and b in 1. So putting the values of a and b, putting the values of a and b in 1. Okay, so let us put those values of a and b in 1. So what do we get? Therefore x minus 1 divided by, what is here, 2x plus 1 into 3x minus 1, 2x plus 1 into 3x minus 1 is equal to, what is capital A? What was the value for capital A? It is 3 by 5. So it is 3 by 5 divided by 2x plus 1, right? And what is the value for b out here? It is minus 2 by 5. So plus into minus is minus. So instead of plus you have to write minus. Plus into minus is minus, right? So it is 2 by 5 divided by what? It is 3x minus 1. It is 3x minus 1. So I think you have understood it. Okay. So this fraction is converted into partial fraction, and this is known as what? Partial fraction. Now we will put this partial fraction in integration so that we can separate the integration and we can easily integrate it. Okay. So therefore this I becomes now, I is equal to integration of within bracket. So instead of this fraction you have to write down the partial fraction, that is 3 by 5 divided by 2x plus 1 minus 2 by 5 divided by 3x minus 1 bracket closed dx, right? So let us separate the expression here, or I is equal to, here 3 by 5 is constant, integration of dx divided by 2x plus 1, then minus 2 by 5 is constant, integration of dx divided by, this is 3x minus 1, right? So or I is equal to, this is your 3 by 5 into, what is this integration? Since here the power of x is 1, you can take this 2x plus 1 as x so that you can easily integrate them. So log, this is 2x plus 1, the base is e, whole divided by, differentiation of 2x plus 1 is 2. So it should be divided by 2. Minus 2 by 5 into, this is log within mod 3x minus 1, the base is e, whole divided by, differentiation of 3x minus 1 is 3. So we have integrated all the terms. So you have to write down plus c. Okay. So in case of indefinite integration, in the answer you have to write down c. I told you already this one. Okay. Or I is equal to, this is 3 by 10 log within mod 2x plus 1, the base is e, minus 2 by 15 log within mod 3x minus 1, the base is e, then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 35. Before that, these two are your homework, that is number 34 and number 36. So in question number 34, it is given integration of dx divided by x minus small a into x minus small b. This small a and small b are constant. You can convert this into partial fraction, that is 1 upon. So in the numerator there is 1 upon x minus a into x minus b. You can write it in terms of partial fraction as capital A upon x minus a plus capital B upon x minus b. Okay, so you can do it. So question number 34 is your homework, and this question number 36 is also your homework, right? This is given integration of x plus 2 dx divided by x square minus 3x plus 2. So in this case you can factorize x square minus 3x plus 2. So you can factorize it, then convert it into partial fraction as we have done in the previous problem. Okay, so these two, 34 and 36, are your homework. Okay, so now this question number 35. Let's do this question number 35. So it is integration of dx divided by x minus a into x minus b. So let us write it as capital I is equal to integration of x dx divided by x minus a into x minus b. Okay, so here also the two factors are given in the denominator. In this case also this fraction is converted into what? Partial fraction. So let x upon x minus a into x minus b is equal to capital A upon x minus a plus capital B upon x minus b, where a and b are constant. And now our work is to find out those values of constants a and b. Okay, so let us find it. Or this is x upon x minus a into x minus b is equal to, what's the LCM here now? It is x minus a into x minus b. These are the LCM. So x minus a gets cancelled. So x a into x minus b plus this is b into x minus b gets cancelled. So it is x minus a. So here you can cancel this. X minus a and x minus b will be cancelled, or x is equal to a into x minus b plus b into this is your x minus a. So I think you have understood it. So let us get those values of constants capital A and capital B by putting some suitable values of x. Okay, so in order to get the value for capital B, you have to make this first term as 0 by putting x is equal to minus b, by putting x is equal to b. Okay, so putting here x is equal to b. So what do we get? Instead of x you should write b is equal to, this first term will be b minus b is 0, that is first term vanishes. So capital B into small b minus small a, or what is the value for capital B now? Small b divided by small b minus small a. So I think I've understood it. Okay, next, in order to get the value for capital A, you should make this second term 0 by putting x is equal to a. So let us putting x is equal to a, right? Let us put x is equal to a now. So therefore, instead of this x, you should put a is equal to, this first term will be capital A into what is x? Small a minus small b, small a minus small b, or capital A is equal to small a divided by small a minus small b. So that is your value for capital A. So I think I have understood it. So now let us put these values of capital A and capital B in 1. So putting the values of A and B in 1, right? So we are putting those values of A and B in 1. Is that clear? So therefore x upon left hand side remains as it is, x upon x minus a into x minus b is equal to, what is capital A? Capital A here is a upon a minus b, a upon a minus b divided by x minus a. Then after that plus sign is there. Let us write plus here. And what is capital B? It is B upon B minus A, right? So it is B upon B minus A. B upon B minus A divided by what? X minus B. Let us write here X minus B. So we have converted this fraction in terms of partial fraction. So let us write down this partial fraction in case of integration, right? So therefore I is equal to integration of, so instead of this fraction x upon x minus a into x minus b, we can write down this partial fraction a upon a minus b divided by x minus a plus b upon b minus a divided by x minus b, bracket closed. Then you should write dx. So I hope you have understood it. Okay. So next, now we can separate this integration, or I is equal to a upon a minus b integration of dx divided by x minus a, right? Next, plus b upon b minus a constant integration of dx divided by x minus b. So you can easily integrate it, okay? Here in the denominator, the power of x is 1. You can take this x minus a as x and x minus b as x, okay? Or I is equal to a upon a minus b. What is integration? What is this integration? Log of x minus a within mod base e plus b upon b minus a log within mod, it is x minus b basis e, then plus c. So you can keep the answer as it is. This may be the answer, okay? You can write it as an answer, okay? But you can simplify it further. Since there is a minus b, you can make it a minus b by taking minus common out here, and then you can take that 1 upon a minus b as common, right? So let us simplify it. Let us simplify it now. So let us simplify it. And let us write down the simplified answer. Or I is equal to, first term remains as it is. First term is kept as it is. A upon a minus b log of within mod x minus a, the base is e. Then here minus is taken common, so it is b upon, minus is taken common from the denominator, that is from b minus a, minus is common. So here it is a minus b, then log within mod x minus b, the base is e, then plus c. Is that clear? So what is common out here? So we can take common here, I is equal to 1 upon a minus b is taken common within third bracket, a log within mod x minus a, the base is e, then minus b log within mod x minus b, the base is e, third bracket closed, plus c. So this is the final answer. So I think you have understood it. So you can copy it, and these 34 and 36 are your homework. Okay. Now we'll do the next question. So you can copy it. So now we'll do this question number 38. That is, you have to integrate integral sine 7x plus 5 dx divided by x cube plus 2x square minus x minus 2. So in this case also, let us factorize the denominator. So first of all, let us write I is equal to, therefore I is equal to integration of 7x plus 5 dx divided by, in the denominator we have x cube plus 2x square minus x minus 2. Okay. So now let us factorize it. Okay. So let us factorize the denominator now. So here denominator is x cube plus 2x square minus x minus 2, minus x minus 2, which is equal to, what is common out here? From the first two terms, this expression is factorized now. From the first two terms, we have x square as common. So within bracket x plus 2, here minus 1 is common. We have x minus 0 minus plus 2, x plus 2. Again x plus 2 is the common factor out here. Then we have x square minus 1. And again x square minus 1 can be factorized using a square minus b square. So which is equal to x plus 2 into, this is here, x plus 1 into x minus 1. So these are the three factors of the denominator, right? So let us write here, therefore we have here I is equal to, this is integration of 7x plus 5 dx divided by, we have what are its factorization? It is x plus 2 into, this is your x plus 1 and this is x minus 1. So again we can convert this fraction in terms of partial fraction. Okay, so let us convert this fraction in terms of partial fraction. Let 7x plus 5 divided by x plus 2 into x plus 1 into x minus 1 is equal to, now there are three factors here. Let us write constant a divided by first factor x plus 2 plus capital B constant divided by x plus 1. Then we should write c divided by what? The third factor, that is x minus 1. Since there are three factors here, we have to write down three constants, that is a, capital B and capital C. So let us mark it as number 1. Is that clear now? So now let us simplify it, and now our work is to find out those values of constants a, b and c. Or now this is 7x plus 5 divided by x plus 2, right, into x plus 1 into x minus 1 is equal to, now what's the LCM here? Here the LCM is x plus 2 into x plus 1 into x minus 1. So now this numerator becomes a into, this x plus 2 gets cancelled, you will have x plus 1 into x minus 1 plus b into, now x plus 1 will be cancelled, you will have x plus 2 into x minus 1, then we have plus c into, so now x minus 1 will be cancelled, you will have x plus 2 into x plus 1. So this is the numerator, right? So here x plus 2, x plus 1, x minus 1 can be cancelled, or now this is 7x plus 5, which is equal to, this is a into x plus 1 into x minus 1 plus, next one is b into x plus 2 into x minus 1 plus c into x plus 2 into x plus 1. So we have got this expression, right? So now from this equation we can easily get those values of constants a, b and c by putting some suitable values of x. Okay, so now here, in order to get the value for c, you have to make these two terms, first term and second term, 0 by putting here x minus 1 is common factor out here. So if you put x is equal to 1, you will get 1 minus 1 0, 1 minus 1 will be 0. So 0 into any number is always 0. This first term and second term will be 0. So let us putting x is equal to 1. Putting x is equal to 1, right? So if you put x is equal to 1, this will be 7 into 1 plus 5 is equal to, this term is 0, this term is also 0. Only c remains here. So 1 plus 2, then 1 plus 1, right? Or 7 plus 5 is 12, which is equal to, this is 3 2s are 6, 6c. That is c is equal to 2. That is, we got the value for c, which is equal to 2. So I think you have understood it. So now let us find out the values of a and b. So now in order to get the value of a only, in order to get the value for a only, you have to make these two terms 0, b and c. So in this b and c, which is the common factor? X plus 2 is the common factor. So by putting x is equal to minus 2, these two terms, second term and the third term will be 0. So putting x is equal to minus 2. So putting x is equal to minus 2. So therefore, now this left hand side becomes 7 into minus 2. 7 into minus 2, right? 7 into minus 2 plus 5. Plus 5 is equal to, now we are getting the value for a only. And this b and c will be 0 by putting x is equal to minus 2. So we have a into minus 2 plus 1, right? And then minus 2 minus 1, okay? This is minus 2 minus 1. So let us simplify it, or this is minus 14 plus 5 is equal to, this is a into minus 1 into, this is your minus 3. Is that clear? Minus 2 plus 1 is minus 1, minus 2 minus 1, same sign, you have to add them, minus 3. Or this is minus 9 is equal to a into 3 ones are 3, minus 2 minus is plus. Or what is the value for a? A is equal to minus 3. We have got the value for a. Since we have got those values of a and c, now you have to get the value for b. Okay, you have to get the value for what? B. By making this first term and third term 0. Which is the common factor here? X plus 1 is the common factor. So in order to make it 0, you put x is equal to minus 1. So putting x is equal to minus 1 now. So putting x is equal to minus 1. If you put x is equal to minus 1 here, this x plus 1 will be 0 and this x plus 1 will be 0. That means first term and second term will be 0. You will get the value for b. So, or 7 into minus 1, this is 7 into x is minus 1 plus 5. This is minus 1 plus 5 is equal to, on the right hand side, first term and the third term will be 0. Only it remains the second term. So it is b into, so b into, what is x plus 2 now? It is minus 1 plus 2. Minus 1 plus 2, then minus 1, right? So this is minus 1. Is that clear? So, or now this is minus 7 plus 5 is equal to b into, this is minus 1 plus 2 is 1 and this is minus 2. Or this is your minus 2 is equal to minus 2b. So here minus minus gets cancels. So what is the value of b here? B is equal to 1. Is that clear? So we get c is equal to 2, a is equal to minus 3 and b is equal to 1. So let us put these values of a, b and c in 1. So putting the values of a comma b and c in 1. So let us put these values of a, b and c in 1. Okay. So in this equation 1, we are putting those constant values of a, b and c, right? So this left hand side will be 7x plus 5 divided by what? X plus 2, x plus 1, x plus 2, x plus 1 into x minus 1 is equal to. Now what is the value for a? Just now we got the value for a as minus 3. So it is minus 3 divided by x plus 2. Minus 3 divided by x plus 2 plus. Next, what is the value for b? B is 1. So it is 1 upon x plus 1, right? So it is 1 upon x plus 1. Next one is plus c. C here is 2. So plus 2 upon x minus 1. Plus 2 upon x minus 1. So we have converted the given fraction in terms of partial fraction. Okay. So instead of this 7x plus 5 divided by x plus 2 into x plus 1 into x minus 1, we will write down minus 3 upon x plus 2 plus 1 upon x plus 1 plus 2 upon x minus 1, so that this integration can be separated and you can easily integrate them. Okay. So what is I now? So I is equal to integration of, so instead of this fraction, you have to write down this partial fraction. that is minus 3 upon x plus 2 plus 1 upon x plus 1 plus 2 upon x minus 1 bracket closed. Then we can write dx. I think you have understood it. Okay. So let us separate this integration. Okay. So let us separate this integration now. So now let us separate it. So let us separate the integration now. So let us separate it now. So in the next step, we can separate the integration and then you can easily integrate them, right? So therefore, I is equal to, what is the first term? Minus 3 integration of dx divided by x plus 2, right? Minus 3 is constant, it is taken outside integration. So integral sign dx upon x plus 2, then plus integration of 1 into dx divided by x plus 1, then plus 2 is there, 2 is constant, it is taken outside. 2 integral sign dx divided by, it is x minus 1. So I think you have understood it. Okay. So next, or I is equal to minus 3. Then what is dx by x plus 2? It is log within mod x plus 2, the base is e, all divided by 1. So if there is, in the denominator, if there is 1, you don't have to write it. Okay. Plus this one is also log within mod x plus 1 base e, because here the power of x is 1 and this x plus 1 is taken as x, and we got this integration as log within mod x plus 1 base e, plus 2 into, this is also log within mod x minus 1 base e. Here also the power of x is 1, so x minus 1 is taken as x, so it is log within mod x minus 1 whole divided by the differentiation of the term which is assumed as x. So what is the differentiation of x minus 1? It is 1. So it is dividing by 1. In the denominator, if there is 1, you don't have to write it. Okay. So it is 2 log within mod x minus 1 base e, then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is this is from Higher Secondary 2015, and this question carries 4 marks, and this question number is 2C number 2. You have to evaluate, that means you have to find out the value of this integration, that is integral sine 3x plus 5 divided by x cube minus x square minus x plus 1 dx. So let us find out its value, right? So therefore I is equal to, let us first write, therefore I is equal to integration of 3x plus 5 divided by x cube minus x square minus x plus 1 dx. Okay. So now in this case also you have to factorize the denominator. So this is the cubic expression. Here the highest power of x is 3. And the highest, here the highest power of x in the denominator is 3, and in the numerator the highest power of x is 1. So we have to convert into partial fraction. So before that you can factorize the denominator. So let us write down the denominator here, x cube minus x square minus x plus 1. Okay. So what is common from the first two from the first two terms? What is common from the first two terms? It is x square. So it is x minus 1. Here minus 1 is common, x minus 1, which is equal to x minus 1 is also common. So it is x square minus 1. Okay. So again, x square minus 1 can be factorized using a square minus b square. So it is x minus 1 into x plus 1 into x minus 1. Okay. So next, this x minus 1 into x minus 1 is x minus 1 whole square into x plus 1, because you can write x minus 1 into x minus 1 as x minus 1 whole square into x plus 1. Okay. So now next, or I is equal to integration of, this is 3x plus 5 divided by, what are these factors? It is x minus 1 whole square into x plus 1, then you should write dx. So I think you have understood it. Okay. Now again, this fraction should be converted into partial fraction. So this is quite different from those problems which we had done in the previous one. That is, in this case we have x minus 1 whole square is there. So in the previous problem there was no whole square. Okay, but in this particular problem we have x minus 1 whole square into x plus 1 is there. Okay, so how can you convert this fraction into partial fraction now? So let 3x plus 5 divided by x minus 1 whole square into x plus 1 is equal to. So now what is the method for converting this fraction in terms of partial fraction? Because in the first factor there is x minus 1 whole square. So always, so you have to remember this method. Always you have to write first capital A divided by only x minus 1. Capital A divided by only x minus 1 plus capital B divided by, you can't write x minus 1 only here. First of all, you should write a upon x minus 1 plus b upon, what should be there? It should be x minus 1 whole square. If you write only b upon x minus 1 plus c upon x plus 1, so on the right hand side, while getting the LCM, will get only x minus 1 into x plus 1 will be there. But here in the denominator we have x minus 1 whole square into x plus 1. So while getting the LCM on the right hand side, you should get the same expression as in the left hand side. That is, you should get x minus 1 whole square into x plus 1. Is that clear now? So that's why you have to write, whenever you have x minus 1 whole square is there, you should write a upon x minus 1 plus b upon x minus 1 whole square. Then you have to write plus c upon what? X plus 1. Then c upon x plus 1. So let us write it as number 1. So I think you have understood it. First of all, you can take a upon x minus 1 plus then b upon, you can't write x minus 1 only, you have to write x minus 1 whole square plus c upon x plus 1. So I think you have understood it. Okay. So or, now this is 3x plus 5 divided by x minus 1 whole square into x plus 1 is equal to, now here was the LCM. So what's the LCM? The LCM is x minus 1 whole square into x plus 1. So I think you have understood it. Okay. So now numerator becomes, now x minus 1 whole square is divided by x minus 1 to get x minus 1. So it is x minus 1 into x plus 1. A into x minus 1 into x plus 1 plus b into, now here x minus 1 whole square will be cancelled, we will get only x plus 1 plus c into, here also x plus 1 will cancel, you will get x minus 1 whole square. So I think you have understood it. Okay. So here you can cancel this x minus 1 whole square and x plus 1 will be cancelled. Or now this is 3x plus 5 is equal to a into, this is your x minus 1 into x plus 1 plus b into x plus 1 plus c into x minus 1 whole square. Is that clear now? So I think you have understood it. So now let us find out those values of constants a, b and c. So if you put x is equal to 1, if you put x is equal to 1, 1 minus 1 will be 0, first term will be 0. This is also x minus 1 is there. In the third term, this 1 minus 1 will be 0, that is third term will be 0. You will get the value for b. So putting x is equal to 1. So putting x is equal to 1. So what do we get? Putting x is equal to 1, what do we get now? So let us simplify it. Here, let us simplify it. So let us simplify it here. So putting x is equal to 1. So it is 3 into 1 plus 5, or 3 into 1 plus 5 is equal to, this first term will be 0, 1 minus 1, 0. The third term will be 0. You will get only in the middle term. That is b into 1 plus 1, right? b into 1 plus 1. Or this is 5 plus 3, 8 is equal to 2b. Or b is equal to, how much is it? b is equal to 4. So we have got the value for b, which is equal to 4. Now if you put x is equal to 1, what do we get? If you put x is equal to 1, this a will be 0. Right? If you put x is equal to 1, right? You put x is equal to 1. After putting x is equal to 1, we are getting b is equal to 4. Now let us put x is equal to minus 1, not 1, because we have already put x is equal to 1 here. Now let us put x is equal to minus 1. So let's see what happens. So putting x is equal to minus 1. So if you put x is equal to minus 1, this will be 3 into minus 1 plus 5. 3 into minus 1 plus 5 is equal to, next, if you put x is equal to 1, this term x plus 1 will be 0. This first term will be 0. This is also minus 1 plus 1, this will be 0. You will get only c. c into minus 1 whole square. c into minus 1 whole square. So we are putting x is equal to minus 1, right? So or this will be 5 minus 3 is equal to c into minus 2 whole square. Or this is 2 is equal to c into 4. Or what is c is equal to? C is equal to half. That is 2 by 4, that is half. So we have got the value for c. So we have got those values of b and c. Okay. So how can you get the value for a now? How can you get the value for a? So how can you get it? How can you get the value for a? Since we have put here x is equal to 1 and x is equal to minus 1 to get the values of b and c. So let us put x is equal to 0. So let us put now putting x is equal to 0. So if you put x is equal to 0, what do we get? 3 into 0 plus 5, right? 3 into 0 plus 5 is equal, if you put x is equal to 0 here, it will be a into minus 1 into 1, 0, 0, minus 1 into 1 plus b into 1, b into 1 plus c into what? This is b into 1 plus c into minus 1 whole square. This is minus 1 whole square, right? So this will be 5 only, which is equal to minus a plus b. This is minus a, this is plus b, and that is your plus c. So I think you have understood it. So let us put those values of b and c. 5 is equal to minus a plus what is b? Plus 4. What is c? Plus half. Right? So what is the value for a now? A is equal, minus a is taken to the left hand side. So it is 4 plus half minus 5. Or a is equal to, this is half minus 1. Because 4 minus 5 is minus 1. So or a is equal to, what is it? This is your minus half. So a is equal to what? What is half minus 1? That is minus half. So we have got all the values of a, b and c. So let us put these values of a, b and c in 1. Putting the values of a, b and c in 1. Putting the values of a, b and c in 1. Okay. So now this number 1 becomes, so number 1 is 3x plus 5 divided by 3x plus 5 divided by what? X minus 1 whole square into x plus 1. X minus 1 whole square into x plus 1, which is equal to, what is capital A? Minus half divided by x minus 1 plus what is b? 4. Here the value for b is 4. So you put it here, plus 4 upon x minus 1 whole square. And what is plus c? C is half. C is equal to half is there. So you put it here, plus half divided by what? X plus 1. So this is your partial fraction. So we have got the partial fraction, okay? So we will put this in I. So actually what is I? So I think you have understood it. So here I is equal to now So I is equal to, let us write here, so therefore I is equal to integration of within second bracket. Let us put the value of this fraction, that is in terms of partial fraction, minus half divided by x minus 1, okay, plus 4 upon what? X minus 1 whole square plus half divided by what? It is x plus 1. Second bracket is closed, then dx. Okay, we have converted the given fraction in terms of partial fraction, and this partial fraction is written in I. Okay, so let us separate the term, or I is equal to, this is minus half constant integration of dx divided by x minus 1 plus 4 constant taken outside, integral sign dx divided by x minus 1 whole square plus half is constant taken outside, integral sign dx divided by x plus 1, right? So we can easily integrate the first and the third term. So it is minus half, what is this integration? Log within mod x minus 1, the base is z. Here you cannot directly integrate it because there is x minus 1 whole square. So x minus 1 whole square, if x minus 1 is taken as x, so it is x square. So it is taken to the numerator. Plus 4 integration of this will be x minus 1 whole to the power minus 2 dx, plus now this will be half log within mod x plus 1, the base is e, then what do we write? Plus c. Because here the power of x is 1, there is also the power of x is 1, that you can write in terms of log, but this is x minus 1 whole square is there, it is taken to the numerator. Now you can easily integrate this integration, okay, and then plus c is written out there. Okay, so next, next one is in the next step we can write, or I is equal to, from first and third, what is common? Half is common. So within second bracket, let us write down the first term, plus term first. Let us write down the plus term first. So half is taken common, so it is log within mod x plus 1, the base is e, then minus, this minus sign is there, log within mod x minus 1, log within mod x minus 1, the base is e, second bracket is closed, okay, and then plus, you can easily integrate this second term, plus 4 into, now in this case, within whole to the power minus 2, the power of x is 1, so x minus 1 we can take it as x to integrate it. So it is x to the power minus 2. What is the integration of x to the power minus 2? X to the power n plus 1 divided by n plus 1. So it is x minus 1 whole to the power minus 2 plus 1 divided by minus 2 plus 1. Actually, which term was taken as x to integrate it? X minus 1 is taken as x. That function is also to be differentiated. So what is the differentiation of x minus 1 with respect to x? That is 1. Differentiation of x is 1 minus, and the differentiation of 1 is 0. So 1 minus 0 is 1. So it should be divided by the differentiation of x minus 1, that is 1. So actually since there is 1, you don't have to write it, or you may write it, okay. Then what do we write? Plus c, okay. So or I is equal to, now let us simplify it, half, you know these properties of logarithm, log a minus log b is log of a by b. So it is log within mod x plus 1 divided by x minus 1, the base is e. Then plus 4 into, this is x minus 1 whole to the power minus 1 divided by, this is minus 1 into 1 is minus 1. Then you should write plus c. or I is equal to, this is half log within mod x plus 1 divided by x minus 1 mod sign close, the base is e, right? Then plus and minus, this is 4 divided by, since the power of x minus 1 is minus 1, it can be taken to the denominator to make it positive. So 4 upon x minus 1 plus c. So this is the final answer. So I think you have understood it. This question is very, very important, and this question is from HS 2015. Okay, so you can copy it. Now I'll give you the homework, right? So now these are your homework. Okay, I'll give you the hints only. This question number 37. Integral sine x square plus x minus 1 divided by x cube plus x square minus 6x dx. So highest power of x in the numerator is 2 and the highest power of x in the denominator is 3. That is, the highest power of x in the numerator is less than the highest power of x in the denominator. So you can directly convert it into partial fraction. Before that, you factorize x cube plus x square minus 6x. You take common first, x is common, then it is x square plus x minus 6. Then you can factorize the expression within bracket using middle term breaking. So you can do it. Okay. So in this case also for 39 you can do it at home. Integral sine x square plus 1 dx divided by x into x square minus 1. So x square minus 1 can be factorized as x plus 1 into x minus 1. So there are 3 factors in the denominator. You can easily do it. So in this case also 40 integral sine dx divided by x minus a into x minus b into x minus c. Let us assume this fraction as capital A upon x minus a plus capital B upon x minus b plus capital C upon x minus a. You can do it. You can get the values of a, b and c using the method that we have done in the previous problem, right? So in 41 also you can easily do it. I will not give you the hint for this question because you can do it. And for this also number 42 integral sine x square minus 3 dx divided by x cube minus 7x plus 6. You know how to factorize x cube minus 7x plus 6. So how can you factorize it? X cube minus 7x plus 6. So let us do its factorization. Okay. So x cube for this. X cube minus 7x plus 6. You know how to factorize this cubic expression, isn't it? Let us factorize it. If you factorize that, if you can factorize that expression, you can easily integrate it. Okay. So is equal to x cube minus 7x plus, then you can write here 7 minus 1, isn't it? 7 minus 1 is 6. So you can take the terms in pairs. So x cube minus 1 and then minus 7x plus 7, right? So this is the formula a cube minus b cube. Here minus 7 is common. So this is x minus 1, right? So this is a cube minus b cube. What is the formula? A cube minus b cube. What is the factor formula? A minus b into a square plus ab plus b whole square. So this will be x minus 1 into what is a whole square? X square plus ab is x into 1 is x plus b whole square is 1. Then minus 7 into x minus 1. Right? So what is common here? X minus 1 is taken common. So it is x square plus x plus 1 minus 7, which is equal to x minus 1 into x square plus x minus 6. Right? So plus 1 minus 7 is minus 6. So I think you have understood it. Okay. Next, again you can factorize this expression. X square plus x minus 6. X square plus x minus 6 can be factorized by middle term breaking, right? So this is x square plus 3 2s are 6. 3 minus 2 is 1. X minus 6. Right? So which is equal to x minus 1 within bracket x square plus 3x minus 2x minus 6. Okay. So which is equal to x minus 1 into within second bracket x is common. This is x plus 3 minus 2 is common. This is x plus 3 second bracket closed, which is equal to x minus 1 into x plus 3 into x minus 2. So these are the factors. So you can write down these factors here. X minus 1, x plus 3, x minus 2. So you can easily convert this fraction in terms of partial fraction. Okay, so you can do it. So in this case also dx divided by x into x plus 1 whole square is there. Just now we did this problem. we did this type of problem, isn't it? That is, in this case, for this 48, how will you convert this fraction in terms of partial fraction? Let for this expression 1 upon x into x plus 1 whole square. This is a upon x plus b upon x plus 1 first. Then plus, what do we write? C upon x plus 1 whole square. You can mark it as 1. So for this problem, we can use this method. So this problem is same as the previous problem that we have just done now. Okay, so these are your homework. So I think we can do it. So this one is for today. So you revise all the problems that we did today and you do all this as homework. Okay, so in the next class we'll do more problems on this chapter, integration of some special form of functions. So this much is for today.